Alright, so let's go through the trial of 2. An electron of mass m, right, has a kinetic energy of E. Show that the de Broglie wavelength lambda of this electron is given to be as such. Okay, so first thing, always go back to P equal to H over lambda. So of course, I make lambda the subject. I will get H over P. So what I need to do now, right, is to relate the kinetic energy with the momentum. So meaning we know that E, kinetic energy, right, is equal to P square over 2m. So with this, I make P square the subject, P square equal to 2me. So square root both sides, P is equal to square root 2me. So you can just sub in. So for example, right, the P you sub inside here. So in turn, you should be able to get H over square root 2me. So this one show already. Okay, let's move on to the next part, the calculation. Calculate the PD, right, through in which an electron initially at rest, so V is equal to 0, must be accelerated so that the de Broglie wavelength is equal to about 0.4 nanometer. Okay, so first I draw a schematic diagram. So there's a positive potential here, negative potential, right? So initially it's at rest. So since there's a positive plate there, so it's going to attract the electron. So eventually it will reach to a certain momentum such that it will give the de Broglie wavelength to be about 0.4 nanometer. So how do we actually do? Very simple. First, you need to do the calculation for the momentum. So you have a de Broglie wavelength of about 0.4 times 10 negative 9. So you calculate what is the momentum first. So I do my calculation, it's about 1.6575 times 10 negative 24. Okay, next, I relate kinetic energy with momentum. So the relationship, as we know, right, is kinetic energy equal to P squared over 2m, where m is the mass of the electron. So you do the calculation, the kinetic energy should be about 1.51 times 10 negative 18. Okay, then after that, what potential difference should I actually give, right, in order for it to accelerate to a Ke of about 1.51 times 10 negative 18? So you just go back to another relationship. So the kinetic energy is equal to Q delta V. So what is Q delta V? Q delta V itself is what we call the electric potential energy. So the so-called loss in kinetic energy will become the gain in your kinetic energy. Okay, so Q delta V equal to 1.51 times 10 negative 18. So what you need to do is to move the Q, right, the elementary charge, to the left hand side. So elementary charge is about 1.6 times 10 negative 19. So eventually the potential difference that you must apply must be about 9.42. So the answer for the PD will be 9.42 volts. So that's all.